Before the silk, there is the leaf. In these humid valleys, the cycle of the silkworm begins with the harvest of white mulberry.
Welcome to the extraction line, where biology meets heavy industry.
Inside the rearing house, the sound of chewing is constant. These larvae will increase their body weight 10,000 times in just weeks.
Inside the rearing house, the sound of chewing is constant. These larvae will increase their body weight 10,000 times in just weeks. When they reach the final instar stage, they stop eating. The biological clock signals that it is time to build.
Two glands in the worm's body produce a liquid protein that hardens on contact with air, a single continuous filament.
For 3 days, the spinning continues until the pupa is safely sealed inside a waterproof, breathable fortress.
The harvest must be timed perfectly. Too early, the silk is weak. Too late, the moth emerges and destroys the filament.
Billions of yards of potential thread, packed and ready for the journey to the reeling facility. Before processing, the loose outer floss is removed, leaving only the structural shell holding the precious filament. Once crated, the cocoons are moved immediately. Time is a factor. The pupae inside are still alive and developing.
The transit must be smooth and temperature controlled. Heat or humidity spikes could trigger premature hatching.
Hundreds of farms converge on a single processing center, creating a continuous supply chain for the reeling machines.
Delicate cargo requires tight packing. Excessive vibration during transport could bruise the pupae or tangle the filaments.
With the load secured, the harvest leaves the quiet of the rearing sheds for the industrial sector. Arrival at the filature. Here, the scale of production shifts from artisanal baskets to metric tons. Payment is determined by weight and shell ratio. Every shipment is logged before the truck backs into the intake bay.
The journey ends at the receiving dock. From this point on, the clock ticks faster.
The environment here is strictly controlled. The transition from nature to machine is immediate.
Intake efficiency is critical. The cocoons are perishable and must be processed or stabilized immediately.
This facility processes 40 tons of raw material daily. It is a machine designed to unravel nature.
Every batch is tracked. The origin farm, harvest date, and breed are logged into the central system. Before the main line starts, a random sample is cut. They check the pupa's vitality and the shell's thickness. If the shell ratio is high and the pupa is healthy, the batch is cleared for the drying chambers. The intake hoppers are the mouth of the factory. From here, human hands will rarely touch the silk again. Vibration aligns the oval shapes, ensuring a smooth, single-layer flow onto the conveyor systems. The first destination is the hot air chamber. This step is grim but necessary. To preserve the continuous thread, the moth cannot emerge. The pupa must be stifled with heat to halt the cycle. Hot air circulates at precise temperatures. The goal is to dry the pupa without damaging the delicate sericin protein of the shell. The weight drops by 60%. The pupa is now inert, and the cocoon is a stable, storable capsule of silk. Rapid cooling prevents the shell layers from becoming brittle. Consistency is key for the unwinding process. Optical sensors detect stains or deformities faster than the human eye. Only the pristine white shells remain. Uniformity is crucial. A large cocoon unwinds at a different tension than a small one, so they must be separated. Doubles, 2 worms in 1 shell, cannot be reeled by machine. They are set aside for spun silk textiles. The sorted harvest rests here to equalize moisture content. A balanced cocoon reels smoothly without breaking. Pneumatic systems deliver the dry shells to the wet processing floor. The environment changes instantly from dry to humid. The sericin gum must be softened. Hot water is the key to unlocking the continuous filament. Boiling softens the sericin, the natural glue holding the silk together. Timing here is critical to the second. Mechanical brushes mimic the human hand, teasing out the coarse outer layer to find the single true end of the filament. Once the true end is found, the thread is almost invisible. A single filament is too fine to use alone. 7 to 10 cocoons are reeled simultaneously. Their filaments adhere to each other, forming one strong, cohesive strand. The crusher twist squeezes out water and physically bonds the multiple filaments into a single, round yarn. As the reel spins, the cocoons dance. A single cocoon can unravel for nearly a kilometer without breaking. When a cocoon is exhausted, the machine detects the drop in thickness and instantly patches in a fresh replacement. Automation ensures the denier, the thickness of the silk, remains perfect, correcting variations in milliseconds. The filaments are now raw silk, but they are still wet, sticky, and require re-reeling to become a commercial product. The silk is reeled, but it is too wet and the bobbins are too small for commercial use. It must be transferred. Re-reeling is the standardization phase. Here the thread is transferred to standard-sized skeins under controlled tension. To prevent the natural gum from gluing the layers together, the thread is wound in a precise diamond cross pattern. As it winds, heat dries the remaining sericin. The gum hardens again, protecting the fiber for shipment. A standard skein weighs exactly 165 grams. When the counter hits the mark, the line stops automatically. The reel is collapsible. This allows the tight skein to be removed without damaging the fibers. Lacing is essential. Without these ties, the diamond pattern would collapse, tangling the silk hopelessly. Compressed into books, the raw silk is ready for the world market. But for high-end fabric, the journey continues to twisting. Raw silk is too fragile for the loom. It must be thrown, twisted with other strands to create a yarn strong enough for weaving. Modern winders run at 10,000 revolutions per minute. The tension is digitally monitored to prevent the slightest sag. Centrifugal force creates a balloon of silk. Every rotation inserts 2 twists into the fiber, doubling productivity. The scroop, that crunching sound, is the hallmark of real silk. The skeins are twisted into compact bundles for transport. Optical sensors watch every inch. If a break occurs, the spindle halts in milliseconds to prevent a defective batch. Static electricity attracts dust. Traveling cleaners patrol the aisles constantly, keeping the high-grade silk pristine. Human hands are too slow for this volume. Automated doffing systems change the cones without stopping the main drive. The twist is energetic. It wants to unravel. Vacuum steam setting relaxes the molecular memory, locking the twist forever. Sensors measure the yarn's evenness to the micrometer. Only grade 6A silk meets the standard for luxury export. For heavy brocades or doubled again, the silk is now a formidable structural material. Precision winding creates a package that can unwind at extreme speeds without snagging. The density must be uniform from core to surface. A micro-layer of anti-static lubricant is applied. This invisible shield allows the silk to fly through high-speed looms later. The package hardness is tested. Too soft, it collapses. Too hard, the delicate fibers are crushed. Under ultraviolet light, mineral oil stains or rogue synthetic fibers reveal themselves instantly. Imperfection has nowhere to hide. Traceability is absolute. The barcode links this specific cone back to the original reeling shift and the raw harvest batch. Silk is hygroscopic. It drinks moisture. Hermetically sealed bags lock in the conditioned humidity level. The packing configuration is designed to prevent crushing. Even inside the box, the silk does not touch the cardboard. Gross weight is verified against the theoretical limit. A variance of even 50 grams rejects the entire carton. Marked for export, these cartons are destined for the fashion houses of Milan, Paris, and Tokyo. While the mainline packs, the lab verifies. A single flaw here can ground an entire shipment. The Sericulture test exposes irregularity. Evenness is graded by comparing panels against international standard photographs. Cohesion measures how well the gum holds the filaments together. It must withstand thousands of friction strokes. Silk is stronger than steel by weight. The serigraph pushes it to the breaking point to prove its tenacity. Under magnification, the cross-section is revealed. A triangular prism shape is what gives silk its famous shimmer. The boil-off determines the precise ratio of gum to fiber. Buyers pay for the fiber, not the glue. Every gram is accounted for. The yield percentage calculates the efficiency of the entire harvest. Whiteness is graded by eye and sensor. The highest grade, 6A, requires a near-perfect neutral white tone. With the lab's seal, the silk is no longer a raw agricultural product. It is a certified industrial commodity. 50 cartons make a pallet. A single pallet holds nearly 1 million kilometers of continuous filament. Just as the worm spun a cocoon for protection, the factory spins a final layer of plastic for the journey. Climate-controlled warehousing prevents the silk from absorbing moisture or becoming brittle before export. The final destination is the textile mill. Here, the raw thread will become satin, chiffon, or crepe. Sealed and logged, the transformation from mulberry leaf to luxury fiber is complete. Thousands of hours of biology and mechanics condensed into a single shipment.
And this is how modern factories produce high-grade raw silk from start to finish.